So let's try another one with a hole. All right, so the first step is to simplify this function. So we're going to look at this x plus 5 over, we need two things that multiply to be 20 and add to be 9. That'd be x plus 5 and x plus 4. So once again, we do have a hole. Basically, this function simplifies, and our new function, the function that we really care about, is 1 over x plus 4. But that factor that canceled, x equals negative 5, is our hole. So we have a hole at negative 5, comma, and if you plug in negative 5, you get negative 1. So that is our hole, negative 1, 2, 3, 4, 5, negative 1. I'm going to put an open circle there to know that that's a hole. Okay. Now I'm just going to use this function to graph the rest. All right. So the x-intercept is where this thing equals 0. So set it equal to 0, and it never equals 0. All right. So we're going to say none. Okay. There's no solution to this equation. If you multiply both sides by x plus 4, you get 1 equals x plus 4. I'm sorry, you get 1 equals 0 if you multiply both sides by x plus 4. So you can't solve that. There's no x-intercept. All right. Vertical asymptotes occur at zeros at the bottom, so negative 4. And that's going to be a vertical, so that's x equals negative 4. All right. Horizontal asymptotes now, since the exponent's higher in the bottom than it is the top, our notes say that that would be the line y equals 0. Okay, so I'm going to graph those things. X equals negative 1, 2, 3, 4 is our vertical asymptote. Y equals 0 is our horizontal asymptote. There's a hole here, so the function is going to look like this. It's defined everywhere except for that hole, and then it goes like this as well over here. All right, there's our function. Our domain is going to be all real numbers except for x cannot be equal to two things now, negative 5 and negative 4. And then our range is all real numbers except for y. So all real numbers, but y can't be 0. Actually, y can't be two things. It can't be negative 1 or 0. All right, and let's just check that in our calculator once again. So go back to y equals, go back to your alpha fraction menu, do x plus 5 in the numerator, and in the bottom we'll graph the original x squared plus 9x plus 20. And we'll take a look at that, and we should see the same function that we graphed, which we do, and there should be a hole here at x equals negative 5. So if I do second calculate value and plug in negative 5, the calculator should give me an error, or undefined. It should give me nothing there. Once again, if you look at your table, at negative 5, you should see an error. You should also see an error at negative 4 because those are the two values for x that are undefined. All right, so you can always check this in your calculator. Okay, I'm running out of time in this video, so I'm going to try to go quick through this one and hopefully one more. But this one, number 6, let's try this one. We got an exponent higher in the top than we do the bottom. Let's factor first. So we pull out an x, and we're left with x squared plus 3 in the top. I'm sorry, scratch that. Let's pull out an x squared. And then we're left with x plus 3 in the top. And then if we factor the bottom, all right, we have x plus 3 and x minus 1. All right, so the x plus 3's cancel, and then our function simplifies to x squared over x minus 1, basically. All right, now those factors that cancel, that's our hole. So x equals negative 3, or as an ordered pair, negative 3, comma, and if we plug in negative 3 in here, we get 9 over negative 4. So negative 9/4. All right. Now our x-intercept is where the top equals 0, so that's 0. So x-intercept is the point 0, 0. Our vertical asymptote occurs at the 0 of the bottom, so that is going to be x equals 1. So we know we have a vertical asymptote here. Our horizontal asymptote now, since the exponent's higher in the top than the bottom, it says that right here there's no horizontal asymptote. All right, now we're going to learn later that's a slant asymptote, but for now we'll say no horizontal asymptote. All right, now what this function looks like, this is kind of weird, and you might need to use your calculator for this. It goes through here and basically turns and goes back up. Basically has a slant asymptote here, but we're not going to skip that for now. We'll get to that. And then the other point that it turns around at is the origin. So it's got to, normally these functions go horizontal at this point, but this one goes back down. All right. So you can graph that on your calculator and take a look at that from now. But the domain is going to be all real numbers except for the values from 1 to 2. I'm sorry, I didn't graph this very well. This goes back to the asymptote. So it's going to be all real numbers except for 1, and then we did have a hole at -3. So it's going to be all real numbers, but x cannot be equal to our -3 hole, and then also our vertical asymptote at 1. And then the range is going to be all real numbers except for these values in between here from 0 to 4. Y cannot be contained in these numbers 0 to 4. If you want to do it as an interval, you know, I don't know. Interval notation's actually probably just better for stuff like this. So interval notation would be -infinity all the way up to 0, including 0, and then as well as 4 to positive infinity. So it's saying y, the y values can be all these numbers, and then also all these numbers up here. So let me write that 1/3 way, and that way would be it's all real numbers, but we're going to say y has to be less than 0, right? Or y has to be greater than 4, but y cannot be equal to -9/4, which was our hole. So that's the one hole that I forgot to graph on here. -1, 2, 3, -9/4. This is a hole right there. So we can't include that y value either. All right, let's just try one more. All right, we'll do number 8. The first step is to once again factor, because we need to see if we have any holes that cancel. So let's go ahead and we need two numbers that multiply to be 35 and add to be 12. So 5 and 7, x plus 5 and x plus 7. And then up here we need two numbers that multiply to be -28 and add to be 3. So that'll be x plus 7 and x minus 4. Okay, the x plus 7's cancel, so we know that those are the whole. So the whole is at -7, comma, and our new function, if we simplify it, is just x minus 4 over x plus 5. So we'll find out what that value is. -7, when you plug it in, gives me -11 over -2, so 11 halves. Okay, next we will find the x-intercept. The x-intercept occurs where the top is equal to 0. That happens at 4. So the x-intercept's at 4, 0. So I'll graph that. 1, 2, 3, 4, 0. All right, I'll graph the whole real quick too, so don't forget. 1, 2, 3, 4, 5, 6, 7, and then -1, 2, 3, 4, 5.5. So there's an open circle there. Okay, vertical asymptote now is going to be, since the exponents are the same, our note said that we have a ratio of the leading coefficients when the exponents are the same, the top and the bottom. So the ratio of leading coefficients is y equals 1. There's a 1 here and a 1 here. So horizontal asymptote, y equals 1. So for horizontal asymptote, it's a ratio of leading coefficients. Vertical asymptote, we take what's left in the bottom and set it equal to 0. All right, so that's x equals -5. That is our vertical asymptote. All right, so I'm going to graph those. X equals -1, 2, 3, 4, 5. Looks like this. All right, y equals 1 is right here. All right, and the function's going to look like this. And I did my hole wrong. I went back and then I went down 5.5, but it's positive 5.5. So the hole's up here. All right, the hole's right there. But that's what the function should look like. The domain is going to be all real numbers except for x cannot be equal to our whole value, which is -7, but also our vertical asymptote value, which is -5. And then our range is all real numbers, but y cannot be equal to our whole value, our horizontal asymptote value, which is 1, and then also our whole value for y, which is 5.5 or 11 halves. All right, so practice these. All the steps are the same, and once again, you can always graph them in your calculator. But hopefully this makes sense, and hopefully this helps, and I hope you have a fantastic day.